The Doman rotor was developed cheaply by mounting it on the fuselage of an R6. These scenes taken in the cow pasture at Stratford, where the early ground testing and flight testing occurred. Here we have Harry Brown, master of the tracking flag, checking the blades for precision of track. My attention was going to strain gauge readings. There was an oscillograph mounted in the ship, which was used throughout all of the testing, from first rotation through ground resonance checks and on up through the flight test program. Giles Montgomery and Harry pondering the chalk marks on the flag. Dick Halpenny in the undershirt, our expert on strain gauge electric instrumentation. Probably consideration of whether we're ready to fly. This is probably, yes, I think this is the shot of the first flight, first time with wheels off the ground. Bob Niels at the controls, feeling it out. Later to come to realize that it was extremely stable and very, very easy to fly. Continuation of the hops on the occasion of the first flight. Here Bob took it into forward flight on the first day, expanding the speeds as we examined and found excellent conditions on rotor strain gauge data. Passing behind the ship a moment ago was the converted barn that we used as a hangar. There'll be a scene later showing the rather comical method by which the machine was partly stored in the hangar. A few days later, we hopped it across the road in order to attend some kind of a little air show that was going on at the Bridgeport Airport, just less than a quarter mile from our cow pasture test site. Here's Niels again. While over there, we made some speed runs up and down the runway with Bob reporting he got up to indicated airspeed something over 100 miles an hour. There were other visitors present. I think later you may see United Aircraft. There it is. Company S-51. Owned, used as an executive transport by United Aircraft way back there in '47. And next, there's a view of a YR-4 that they were, yes, here we are, YR-4 rotor head and cabin. Back to speed runs up and down the runway. Ah, yes, it says on the old title, 105 miles an hour. At this point, Bob Niels was pretty elated about the smoothness, maneuverability, fingertip control, and so on. Just a great flying machine. he was still working as vice president of Wareham Knitters up in Wareham, Mass, and had to fly down to do the occasional flight testing for us, which meant we usually did these things on Saturdays or Sundays when Bob was available. Yeah, here's going to be, yes, here's a scene with Bob dangling a leg out of the cabin and demonstrating that it took a very few pounds at the grip of the stick to handle it. Here's Giles Montgomery demonstrating the pre-universal tilting characteristic of the rotor. This ship was acquired from the Air Force on a bailment contract where we paid $1 and other good and valuable considerations to the Air Force. It was a brand new Nash Kelvinator built Sikorsky, which was one of several hundred built. It was sitting in a crate at the factory before the government shipped it to us. It had never been delivered because the Nash people had not been successful in tracking the rotor blades. Here we are, the famous hangar contraption, which attracted almost as much attention as the helicopter itself. See the props being taken out one after another to work the blades back onto their shelves under the eaves of the barn, closing the tent like cover. And yes, here we have just arrived at Danbury, where we've leased new quarters. Bob Neal's, no, I don't know who Stinson that was. Somebody Stinson that accompanied us over. I flew over from Stratford with Bob. These are scenes from a sort of barnstorming tour that we made down through Delaware and Maryland and to Washington. Scenes at the Belenka plant where we demonstrated to Giuseppe Belenka. The Glen L. Martin plant. Glen L. Martin, the man, at this time was considering an investment in the company. And, back so soon to Danbury. Our Fred 1950 Studebaker posed beside the ship. Notice bob weights hanging off the leading edge of the blades. CW-40 coming outdoors for the first time to check fuel systems and to make a trial run of the engine. This ship was, construction of this was started in probably January 1951, and first flight occurred in October of 51. Don Smith. Apparently looking for a gas leak under the belly of the ship. Yeah, or what are they doing? I don't know. Jan North. Don Smith again. Assisting us in the construction of this ship were a group of mechanics that were loaned to us from Curtis Columbus. There's the infamous cooling fan, which greatly impeded the performance of this ship because it consumed about 60 horsepower out of a total of 400 horsepower available from the engine. so it impeded the performance quite a bit. Outdoors again for early ground runs. During this time there was a minor engineering crisis when huge sporadic forces occurred in the control system. Wasn't understood for several days, but turned out to be due to an error in the type of bearing delivered by, I think it was probably MRC. Out again with the blade bearings changed. Notice that the rotor had no restraint of tilting when it was at rest, giving it a very awkward look when not rotating. Yes, here's a start where you'll see the rotor straighten itself up as it comes up to speed. This rather odd feature was corrected in the later ships by installing centrifugally actuated stops that held the rotor horizontal when it wasn't turning. More engine runs and tracking adjustments. Probably this was at low speed. There'll shortly be a scene of the ship running up to full speed and power, restrained by ropes held by people on the ground, so-called ground resonance testing. There we are, wrapping the ropes around stakes, getting ready to go to full power and full speed, and with the usual trepidation about possibility of a grounded stability, which never did occur, but critics of the rotor were quite worried that it might be a problem. Lee Gobin, the inspector from Curtis Columbus, Montgomery, still acting chief of blade tracking deliberations, Jan North adjusting oscillographs. As was always our practice, we recorded rotor stresses and general dynamic conditions through any advancement of the testing of a new ship. Always getting very pleasant results. As was often the case, first flight of this machine occurred just after sundown, so we have a relatively dark picture here, but we should see air under the wheels somewhere. Yeah, there we are, just lifting off, I think. Yes, just lifting off. Not very thrilling first flight. I think it only hovered that night, maybe advanced slightly. This ship didn't require much of any adjustment of control sensitivity or factors like that. Had good flying qualities from the beginning. However, the terrible power consumption by that cooling fan was the subject of a lot of effort at improvement. We finally concluded that we could not fan cool the engine for less than about 10% of the total horsepower because it took a large pressure drop across the cylinders to cool it. Don Smith at the controls, view of the blade with no finish, just the mahogany external skins. I believe this was not the second flight, but close to it. Whether it will fly away here, I don't know. Notice the lack of covers, doors. This reflected the urgency to do flight testing rather than finish up the cosmetics. When the ship went back in the hangar for some reason, the work to finish up sheet metal would continue or be resumed. Can't tell who's flying here, but could have been Connie Moeller, another engineering test pilot from Sikorsky, who occasionally flew for us when Bob Niels wasn't available. More after dusk flying, which was not unusual. I guess we're going to get into forward flight here. Yeah. While this ship was flying, word about it went out through the industry, and various military types were constantly visiting and flying in it and asking what we were going to do with it. The best we could say was that it was owned by Curtis Wright, and Curtis hadn't made up its mind. So we sold the YH-31 to the Army after a show of the mock-up, advising Curtis that the exclusive license which we had granted them was terminated, and proceeded to create the YH-31. Here a scene of a visit by Army people in an H-19 before the first flight. Army interest in the machine was really intense, and we had a feeling at this point that we probably had it made. Here we had anticipated a first flight, but oh, there's the young inspector, Steve Doman, waiting for the big event. We had a failure of a supercharger drive shaft, which postponed the flying for a couple of days. Here, the first flight finally occurring after dark, as usual. From the first moment, flying qualities were something to rejoice about. Here, Pete Parisi and Norm Grizzle making a tail rotor adjustment, Bob Niels departing in his Bonanza. Here is a faked first flight, which occurred the day after, where we had daylight for newspaper coverage purposes. Turp Gerard feeling the machine out. At this time, there were no servos. Rejoiced in the excellent stick forces and control behavior of the machine. Also, note the lack of a cooling fan, the machine being cooled by exhaust ejectors. This exhaust system was really wonderful because of tuning of the exhaust pipes between the cylinders and the nozzles. We actually had better aspiration and got around 410 horsepower instead of the rated 400. So we had gained almost 70 horsepower over the situation with the same engine in the CW40. Here passengers to get photos to send to an agent in Japan who Montgomery had visited and signed up. This was done before the sheet metal was complete. You'll see if Terp turns the ship around, you'll see that the other side was open. Yes, here we are. Look at that. Anyway, 8 people off the ground for the first time. Ernie Woda, Jack DeForest, a young man in the front seat whose name I don't remember. He was a newly hired stress analyst. Terp Gerard, Giles Montgomery. A series of auto-rotation landings. These ships were marvels for their auto-rotation characteristics. Very efficient rotor and high inertia rotor gave them a rate of descent power off of only about 500 feet a minute and the ability to flare it very easily. What's going on here? Okay. I think probably more auto rotations. Yes, here we are. During these days there was a continuous traffic of people looking for demonstrations and demonstration rides, especially military personnel visiting. We were getting great support from Lycoming, who went ahead and built 10 engines on the cuff, more or less, since we didn't have the capital to pay for them. They were getting word from the top brass and Pentagon that this project was a hot one and would definitely go on into production. Little did we know that about this time the Air Force was mounting a campaign to shoot us and the Army down. They positively did not want these ships to go on into production without Air Force engineering control. A view of the rotor hub, which was pressed steel weldment, weighing only maybe 42 pounds when, excuse me, I think it was 52 pounds before machining and ending up at 48 pounds. This was done in order to obtain a type certificate on a production-worthy design. It took quite an investment in tooling. The hub on the prototype of the CW40 had weighed about 1,100 pounds before we started machining it. From a hand forging, it was machined down to something like 55 pounds. Here is an appearance, first time away at an air show, probably in 1954. This is a Washington scene. No very, important scene. Michael Glurup with the bald spot, chief engineer of Sikorsky. Bill Bunker with the glasses, Colonel Bunker, the famous, in the hat. Paul Stanley, the patent attorney for Autogyro Company, looking to see what he could sue us on. Some HUP Piasekis. What is this? Oh, a command. HU2K, I guess. A Hiller 360. A Bell H-12, an engineering and financial disaster for Bell. Project later canceled. Sikorsky S-52, Bell H-13, the MASH machine. Kawasaki H-21s, which went to Korea and spread parts all over the landscape. Here we have Ship 3 emerging from a hangar at Fleet Manufacturing in Fort Erie, Ontario. We had licensed Fleet and formed a jointly owned corporation, 50% Doman, 50% Fleet, to have the machines final manufactured in Canada. This one was built with tooling that we shipped to Canada, fuselage tooling. As usual, first flight without finished sheet metal and paint, etc. In the cockpit, Turp Gerard checking out Dennis Bryan, who was a pilot from Ferry Aviation in England, who was hired by Fleet. Must be nearing first flight here. By this time we had gone to optical tracking of the rotor blades. Yes, here we are, first time off the ground. Ship 3. This ship was to be the vehicle for blind flight experiments and demonstration, instrument flight trainer demonstrations. It went to France for demonstrations and evaluations to the French military, sponsored by Avion Marcel Dassault. It was eventually modified to the D-10 configuration and flew barnstorming tour of the oil patch in Oklahoma, Louisiana, and Texas. We trying to persuade the oil companies that they ought to be using helicopters in the offshore oil service. They were saying not yet. About this time, the Air Force was well along in killing off the prospects of a production series for the Army, and we were moving to try to get into commercial production. Here we have the ship appearing in Canadian paint, about to start off on the barnstorming tour of Toronto, Ottawa, Montreal, etc. Conducted by Fleet personnel in the name of Doman Fleet Helicopters Limited. Here we have an arrival in Danbury, probably after a show in Montreal. Shortly after this ship was packed and shipped to France for the demonstrations that I mentioned. I think we had a near miss there. The French were relying on getting alouettes for use in Algeria, but due to technical difficulties with the rotor, they couldn't get delivery, and Marcel Dassault came close to selling this machine. At one point, I had a cable from Turk Gerard very upset because Dassault had mounted machine guns on the ship and were headed for combat demonstrations in Algeria. Demonstration of the weight carrying capacity, hauling a Volkswagen convertible. Due to the ejector cooling having replaced the fan, this machine had gained probably, what, 800 or 900 pounds of lifting capacity with the same power plant. It greatly increased the utility and, of course, the range of the machine. Visit by Army personnel. These were demonstrations promoted by Ward Davis of the ability to fly the machine blind using a device which we call the rotor attitude indicator, which made it easy to fly the machine blind with the conventional airplane instruments. I guess here we have the commercial ship mixed in with the two Army types. These scenes were before the type certification. It's interesting to note that even the flight demonstrations in France went ahead under experimental registration of the ships. Neither military machine was yet decorated in the official military paint. Back to Ottawa. Probably flying before VIPs or government officials. Unfortunately, there are no films of the activity in France. Some landscape scene, I think, in Ottawa. our financial difficulties created by the SEC's objecting to our registration and really brought about or made worse by the Air Force blocking the Army procurement. We thought at this time that fleet's capabilities would probably be the out for us, but fleet itself ran into difficulties, financial and management-wise, and in effect handed the Doman Fleet Limited back to us in the hope that it, and of course the aircraft came along with it, in the hope that we could use it to get into commercial production. Here, a visit by military types, I'm not just sure who, some Navy there, some, yes, there's the Naval Air Test Center. They were angling to get one of the two YH-31s, since they had the word that the Air Force was going to block the Army. Eventually, the Navy did take the second military ship and tested it at Patuxent for about a year. Great enthusiasm about the technology of the rotor, but no particular interest in the aircraft as a potential Navy machine. Nearing type certification, we flew for about a week on the routes of New York Airways, seen here. This was a final step requested by the FAA for the granting of the type certificate, or before the granting of the type certificate. Scene of the parkways in Queens. Back to Danbury with the type certificate. Ah, yes, painting off the experimental, indicating that we are now FAA certificated. Some maneuvering demonstrations for FAA people, if I remember correctly. Gerard demonstrating flying a 150-foot square. Visit by Colonel Stu Gregg using a military airplane. He visited us in the uniform of a reserve Air Force Light Colonel. Later came to work for us as a commercial pilot and sales manager, and flew the demonstrations of the D-10 barnstorming through Italy, up to the Paris Air Show and back to Italy, sponsored by Air Italia, strangely the company which 30 years later hired me to develop the big wind turbines. colleague and friends departing with a military airplane with strange markings. I'm not sure what it was. Preparations for the departure of Ship 1 to Port Rucker. Ellis Hill, the project pilot, Turp Gerard, climbing in for the takeoff. We had induced the Army to take the two machines, even though the Air Force had really succeeded in blocking further production. Again, a stopover in Washington at an air show. The day following this show, the ship demonstrated at the Pentagon helipad, where General Hamilton Howe is the Chief of Army Aviation, and General Paul Yount, Chief of Transportation, and the famous Bill Bunker, Colonel, Army Transportation Corps, flew, congratulated us, spoke of their hopes that we would yet overcome the Air Force. Sikorsky H-37, a unique machine. The Bell HSL, another technical disaster on which the government lost about $150 million. Joan, speaking with a TV celebrity, Herb somebody, on the ramp at the air show. Being newly certificated, we had a little bit more lively demonstration there at that Washington show. Scenes after the arrival at Fort Rucker, where this ship number 1 was flown for 6 to 8 months by evaluation board 6. In the deal with the Air Force, they issued a report indicating that there was no requirement for the machine. This upset the Army personnel who'd been flying it and loved it. We thought that the jig was up at that point, but Paul Yount stepped in and took the two machines for evaluation by the Transportation Corps Technical Evaluation Command. Here we have Art Tucker preparing for a flight. Probably to Newark, New Jersey for a press show put on or promoted by Ward Davis. Notice that Joan was on the ramp there, having accompanied us to Newark. Steve in the co-pilot seat headed out toward the Statue of Liberty. This scene is a little out of sequence since films of the departure for Newark come later. Yes, this is back. No, this is at an AHS sponsored show in Washington, because this is the red ship at Washington National. Harvey Gaylord, president of Bell. Sikorsky S-58 in company colors, being used as United Aircraft executive transport. The infamous French Alouette, which had been our downfall in Paris, since Aerospatiale had solved the technical problems and finally delivered them. Single place coaxial. Joan, Steve, Ward Davis, and myself. Yeah. Ward. Steve. Joan looking out the window as we approach the Statue of Liberty. An intimate view of the lady. Demonstrations in Long Island for some British types that were brought in by the infamous Louis Walker. Departing for who knows where. I remember using this ship one day to get to a board meeting at Louis' house in Syosset, Long Island, when we were snowed in Danbury. Art Tucker called me and said he could get us out of the backyard in the deep snow, and he did so. flew across the sound to the island. What this is, I don't know. More auto-rotation landings being made, demonstrating to somebody. Here's a version of the machine stripped for increasing the load carrying capacity. It was certificated to fly this way or fully clothed. Another view of the rotor system. This is ship number 2 dressed up in preparation for departure for Fort Rucker and the transportation test command. I don't know what that whirling maneuver was for. Probably at this point, Turk was checking out Army project pilots. Oh, this was a little joyride which we took to give rides to various employees that wished them. Gerard showing how the machine could be trimmed up to fly hands off and cross country. And here controlling it either hands off or with the fingertip in hover. Another scene, hopping employees looking out there at the Danbury Fairgrounds, packing up to fly to Fort Rucker, Turp Gerard, and arrival at Fort Rucker. I think, oh, what do you know, an auto-rotation landing. I think coming up here shortly are a series of power chops from hovering flight and from takeoff and climb out conditions. Yeah, there's a power chop. Another one. Another one. Here he started to climb out and then suddenly cut the engine. Transition to auto rotation and landing without power. Another one. Another one. This ship was flown many hours a day, accumulating a great maintenance record. But unfortunately, no cigar, no production by the Army. This wide open cabin was a first in this machine. It's since been emulated by other people. Here's some demonstrations, I believe by Art Tucker, of the maneuverability of the ship. Here it's in the configuration that from Italy up to the 1960 Paris Air Show, and back to Italy. Unfortunately, this ship never resumed flight after return from Italy because some critical rotor parts were lost in the shipment back across the Atlantic. It was, this ship was in effect replaced by military ship 2, which we purchased from the Navy and converted to the red and white commercial configuration, which was the mark of the effort while we were in Puerto Rico and after return to Pennsylvania. That ship, number 2, was loaned to the Hiller Museum, and Hiller, due to his infatuation with it as one of his efforts, restored it to the military configuration, and when he placed it in his museum in Palo Alto, California. These demonstrations by Art Tucker are a little bit more hyperactive than... So, the original prime objective of the rotor development was to eliminate the Coriolis effect, which had plagued both autogyros and helicopters due to blade stresses developed by the flapping motion of the blades around the hinges which everyone was using. So the objective here was to allow the rotor to tilt freely under cyclic control or external forces, so that there wouldn't be any mechanical flapping and no generation of the in-plane forces which led to blade fractures. In addition to that feature, the objective was to achieve a good Campbell diagram, that is to say, have an excellent placement of all the natural frequencies of various modes of rotor bending relative to the excitations. Having eliminated the Coriolis force by allowing the rotor to tilt freely, there remained in-plane once per rev forces, which would be felt by the blades in forward flight. This, of course, was a secondary reason for the use of drag hinges in typical helicopters of the time. Drag hinge allowing the blades to move up and downwind, or lead and lag in the plane of rotation. In order to attenuate the loads felt in this rotor, the blades were designed to have a natural frequency below 1 per rev, a feature which is now called soft in-plane rotor. The rotor on the R6 originated this, and it's interesting to note that today I would say the majority of the manufacturers in the world have at last come around to doing it that way. Even Bell, that clung for years to the teetering two-bladed rotor have now converted all of their current models to four-bladed soft in-plane rotors, following essentially the principles that were applied by us to the R6. When we got into forward flight, we found that the in-plane bending loads were somewhat higher than I had expected, and it was concluded that the blade was a little too stiff. We removed the blade shanks, put them in a lathe, and removed some outer wall material, reducing the strength of the blade shank by perhaps 20%, but at the same time reducing the measured stresses by more than 50%. Another factor that we found it needed improvement in the first version of the rotor was that the, what should I say, the first in-plane collective mode fell at slightly above 4 per rev at normal RPM. And it was, it could be excited by its reduction of natural frequency when steep turns were made, pulling around 2 Gs and bending the blades upward. This was corrected by removing the original stainless steel leading edges and replacing them with nylon. Also an interesting fact, the first flying was done with both positive and negative delta 3 effects. We were interested in the influence of that factor on flight path stability, but we found that the positive delta 3 tended to make the first unsymmetrical out-of-plane bending mode go unstable. That is to say, go self-excited, build up tremendous stresses. We therefore swore off of positive delta 3 and always flew both the R6 and the later ships with negative delta 3, which fortunately not only made that rather dangerous situation in the unsymmetrical flatwise bending self-excitation very, very stable and kept the stresses in that mode very low. We also found that the 4 per rev first collective in-plane mode, which I referred to before, was badly excited by chattering friction in the Sikorsky centrifugal clutch, which was used for starting the system. We fixed that by replacing the Sikorsky clutch with a so-called fluid drive from a Chrysler automobile at the time. A great deal of effort was given to precise chordwise balancing of the blades, that is, placing the chordwise CG of all the span-wise elements precisely on the aerodynamic center. Having done this to the best of our ability, in the detailed blade design, we found in flight test that the aerodynamic center was slightly aft of where NASA data had indicated it should be, and we made balance adjustments to make this make the chordwise balance in essence perfect. This resulted in very, very small pitching moments being developed in flight, and and gave us the opportunity to achieve truly fingertip control with no servos, that is, no power boost on the controls. Later on, we hung what we called bob weights off the leading edge of the blades at the inboard end, noticeable in some of the pictures. Those bob weights provided a gyroscopic effect, which contributed to flight path stability, hands-off, in turbulent air and forward flight. We made a bit of a splash by making a trip from Danbury to Brewster, New York and back without touching the controls, demonstrating those advantages. The big drawback with the R6 was that the rotor was driven by a commercial tracta, T-R-A-C-T-A, constant velocity universal joint, which really wasn't up to the slow speed and high torque, and gave us a constant wear problem. That problem in the R6 led us to a change in the CW40, where we ran a tractor joint at a high speed, higher than rotor speed, which was enabled by placing a planetary gearbox on the top of the whole system, above the rotor hub. Thus, the tractor joint shaft running up through the center of the system ran at a fair multiple of rotor speed and at a lower torque. That was quasi-successful on the CW40, there being some continuing wear. CW40 used the same blade design in outboard and was essentially created by extending the blade inboard. Thus, it had the same advantages of extremely small stick forces due to the excellent chordwise balance, and the ship was also flown with bob weights, contributing to its flight path stability and hands-off flight. In this rotor, due to the much larger diameter and longer steel tube blade shanks, the first collective load, which had been difficult to bring down below 4P at rotor speed on the R6, came way down to perhaps 65% of rotor speed, and so it was never encountered in flight. To avoid it in startups, the CW40 had a small hydraulic clutch which would bring the rotor up through that mode, and then the shaft locked up through blocker ring, and the drive became a stiff one. Went up at flying speed. You'll notice that the fuselage structure of the CW40 failed to give us complete wide open doors on the side, which were desired for the loading of cargo or litters or what have you. We simply didn't invent at that time a structure that would do the trick. Also in the forward upper part of the fuselage structure, there was a very heavy transverse bridge which carried the lift and torque into side trusses along above the doors. And those trusses being so thin, that is to having such a small vertical dimension, were necessarily very, very heavy. That was changed in a major way in the YH-31 design. As I said before, the tracta joint was not really satisfactory in that the wear was excessive, probably a joint lasting only 200 or 300 hours. Therefore, in the YH-31 design, a change was made where we went to cardan joint and a quill shaft, still turning at high speed with the planetary gearbox on the top of the rotor, but this provided that flexibility, torsional flexibility, which permitted a single cardan to operate really satisfactorily, eliminating the need for a constant velocity joint as such. Biggest change in the YH-31 LC5 was the introduction of exhaust ejectors, where nozzles on the exhaust pipes drew the air through mixers and diffusers, and thereby sucked air through the cooling fins on the cylinders. Due to extensive laboratory testing done by Steve DuPont at a dynamometer facility of Lycoming in Williamsport, the exhaust stacks were all tuned so that they really almost sucked the exhaust out of at the valve, and made the engine breathe so much more at the same manifold pressure that we got 410 horsepower out of it, where we, in the normal rating of the engine, we would have only had 400 horsepower. This gave us a lift advantage of about 800 pounds and a terrific improvement of the payload versus range capabilities of the machine. Also in the D10, Steve continued his development and converted the diffusers in the ejector system to silencers. So at the end, the ejector cooling system was really a major success. The fuselage structure, it may have been noted, permitted the wide opening of the doors without the restriction, diagonal restriction at the rear door. This was accomplished by sweeping the structure inward from the aft cabin to the rotor head, carrying the torque load directly back into the tail structure, and then supporting the front end or pilot compartment engine end of the assembly with the diagonal struts paralleling the drive shaft, so that the effective truss depth for carrying the thrust loads was very, very deep, and the structure in that area probably was reduced in weight by 80% over what it had been in the CW40. Another feature which we adopted, which was unique at the time, was an overload clutch in the tail rotor drive system, because we had noted in the CW40 that wig-wagging of the rudder pedals would build up torsional load swings in the tail rotor drive, and persistence by the pilot, who might not understand what he was doing, could easily simply shear the drive shaft. Just as I was explaining that feature to the FAA, Sikorsky S-55s began to have a rash of tail rotor drive failures due to this. So we pioneered the solution by putting this overload clutch in, and never had such a problem. I guess the final detail improvement, which we put in after the first certification, was a servo control system on both the cyclic and collective. I certainly was reluctant to do that because we had such low forces and remarkable manageability of the machine without servos. But just as one doesn't want to give up power steering on the automobile once it's had it, we found that everybody said, well, why don't you put servos on it anyhow? Rather than hang hardware on the outside of the system somewhere, which was typically being done by others at the time, we incorporated the servo in a casting which mounted the swash plate inside the rotor head, and the entire system operated on transmission oil, had only one input oil line and a pump, no tank, and essentially no discernible external plumbing. It was really a marvel of detailed design, accomplished largely by Steve DuPont and his friend Dick Bewley. With this, I run out of recollection of peculiar design features, but I should emphasize that as the design evolved, especially speaking now of rotor dynamics and structural dynamics, as it evolved, we came to an almost ideal Campbell diagram situation with all of the natural frequencies of the rotor and of the drive system very ideally placed, so that cyclic stresses in the system were just virtually non-existent. I doubt that any helicopter before or since has been as successful in accomplishing that. What else? I guess I'm out of ideas. I forgot to mention that our tail rotors were also hingeless. On the R6, we did keep the Sikorsky rotor, which was three-bladed with flapping hinges. But on our own machines, the rotor, although it was structurally rigid, was free tilting like the main rotor and free of any Coriolis effects. The result of this was very little stress effect from either forward flight speed or rapid rudder turns. Let's see, another item concerning the main rotor blades. They not only had this feature of extremely carefully devised chordwise balance, but also they had a span-wise distribution of slugging, which gave them the same unit weight per inch of span all along the span. This resulted in the blade operating with virtually no steady bending component and permitted the feathering for control to occur without the increased polar inertia that would be involved if the blades bent within themselves or bent substantially relative to the pitch bearings at the hub. I think it should also be noted that the hub geometry was adjusted to both a coning angle and a lead lag angle, which would result in zero steady bending when in operation. One other point, my comment about the trip where the R6 flew to Danbury to Brewster and back without touching the controls may have sounded incredible. What I meant to say was that there was no change of the cyclic or collective controls during the trip. Altitude was adjusted by adjusting the throttle, and the ship was steered and turned by use of the rudder pedals. Actually, when steered by the rudder pedals, the system would exert quite an accurate bank response. So again, I think I am out of ideas. We succeeded in eliminating grease fittings from any part of the helicopter other than the landing gear. This was certainly unique then, and even today some types have numerous grease fittings that require attention. In those days, the articulated rotor heads were strewn with grease fittings that had to be given daily or hourly attention to keep the hinges in the rotor systems from failing. This resulted in a terrible reliability problem for the helicopter types of the time. Let's see. Now I am certainly without further ideas, so let's say finito, basta così.